All right, problem 83 says, what is the area enclosed by the curves of y defined by this cubic function and y defined as this line graph here? I will use my calculator really heavily for this one, but just a comment real quick. Before you punch things into your calculator, you want to always try to be a little bit smarter than it is. So let's visualize, like, what does a cubic function with a positive leading coefficient look like? So I hope it makes sense. We're kind of expecting that has something that has this shape for the cubic function, and we all know what line graphs look like, especially with the positive slope. So depending on where the line graph lands, like, it could intersect with the cubic function in just one place, in which case this problem would not make any sense. There would be no enclosed area. Or it very rarely could intersect with the cubic function in two places. If it's like perfectly tangent and then hits it in another place, then you just have one little enclosed region. But most likely the line graph will come through and intersect the cubic in three places, and then that would create two regions for us to need to find the enclosed area of. So I'm going to go ahead and make my calculator graph the two functions. I've typed them in, and then for the window, you'd likely start out at like -10 to 10 and then using like a zoom fit type deal. Let's see what it shows us, if we like it or not. So here is the cubic function, and then I guess I barely saw something happen over here for the line graph. So let's look and see what window it chose for us. Oh, goody, negative 2,000-ish to 375. So I don't want all that. I feel like it was too scrunched vertically. So let's change that. Let's go, like, I don't know, let's try negative 200 to 100 or something and try again and see what happens. There's the cubic function. Okay, and I can see a little more happening with the line graph, and I feel like those intersections that I'm looking for are happening somewhere in here based on what I see. So I'm going to demonstrate box zoom. So it's actually my favorite zoom, and I don't get to use it very often, so I'm kind of excited. So with box zoom, you move the cursor to where you want one corner of your box to be, push enter, and then move the cursor around, and then your calculator will draw a box. Did I make this the right size? Let's hope I did. Oh, I don't know if I got it big enough. Anyway, it will, whatever you have enclosed in the box, it'll fill the whole screen with that. So let's see, here's the cubic function. Boom, come on, line graph. 1, 2, 3 intersections, awesome. Okay, so I wanna know what are the X values where those 3 intersections happen. It looks like it happens at 1 and 2 and 3, 4, 5. 1, 3, and 5. So one thing you could do if you don't want to bother with the intersect feature is you could plug 1 in to both and see if you get the same thing. So let's do that. 1 minus 8 plus 18 minus 5, negative 7, 6, and 6. So you could tell this is at x equals 1. And then you could do that with 2. Let's see, you get 7 on the line graph, and you would get 7, yes, so this does happen at x equals 2. So, and then the other way, I'm just going to demonstrate it on 1 so I can avoid the repetition in the video, but you also could have used the calculate feature and then gone to intersect, and then get close to whichever intersection you're wanting it to find. So let's say I'm wanting it to find this last one. So you're just like trying to make sure that it's as simple as it looks. And then yeah, so that is indeed at 5. Okay, so now that I know where the x values, where the 3 intersections happen, now I'm just going to set up integral expressions using the idea of upper minus lower. So to find the area of that first enclosed region, I would just do the integral from 1 to 2. And then upper minus lower, I have, this is called y1, and this was y2 in my calculator. And on multiple choice, it's okay to use kind of this snaggly notation because it's just for you. But on FRQs, never write Y1 or Y2. They don't like calculator lingo on FRQs. So if you do this, then it's just for you. And don't let anybody who's grading you see that kind of notation. And then for this region, we do the line graph minus the cubic. So that would be Y2 minus Y1, like that. And so this is my plan. So let's just go about it. So function integration. Oh boy, let's get out of here. Now let's do that. So that's the first integral. And then we're going to add it to the second integral. Oops. And we get 11.83 repeating. Which matches up with B.